Okay, so I just want to do a brief exploration. So this can be just for the next couple of minutes here, could just be sort of a sit and think instead of a work really hard. So if you can just sort of relax, think about what I'm going to show you here, and we'll see if we can make this make some sense. So this is a little GeoGebra demo like what we did the other day. Recognize that? Yes? Okay, so check this out. I'm going to change our function over to e to the x, and I'll just enter that. So this is when x is approximately, let's see here, I'm going to go x equals 1. So I'll go here and just so the numbers are fairly easy. So that's roughly x equals 1, right? 1.003. So is it a big surprise to you that the tangent line looks the way that it does? What jumps out to you? We've done this before. What jumps out to you about the tangent line?
It goes through the origin.
Okay, it goes through the origin. I'm more referring to the tangent line equation, I should probably say. What about the tangent line equation? Slope and, what do you think, Luke?
Well, we were talking last week, isn't it normally the wires that top doubles if it's related to the slope, it wasn't the exact same.
Okay, so we did talk about stuff like that. That was with the chain rule, right?
Okay.
But this is just e to the x, right? So what's the derivative of e to the x? So doesn't it make sense then that oh, you can't see the mouse. If the derivative of e to the x really is e to the x, doesn't it make sense that the y coordinate for the point of tangency and the slope would be the same?
Yeah.
Does that ring true? Now, of course, if we make it e to the 2x, now we get that doubling effect, right? E to the 5x, we get a multiply by 5 effect. Okay, so this makes sense, okay? Yes? So I want you to remember this. So think this through. I want you to remember that for e to the x, the derivative of e to the x at 1 is 2.727. So maybe take a second and write that number down. Maybe write, I don't know, the derivative of e evaluated at 1 approximately is 2.727. Okay, so I'm going to do a different function now. This is definitely going somewhere, so just be patient with me. Instead of e to the x this time, I'm going to write cosine of x. Cosine of x. Okay, so obviously a very different graph. So you would expect that a lot of the key features of the tangent line would be very different from e to the x, and you can see that that's true. I did leave the x coordinate at 1.003, approximately 1. And what's the slope of the tangent line at that point? Negative 0.843, agreed. Okay, so this number right here, will you write that one down also? You wrote down that other 2.727. And this one here, I want you to write this one down, negative 0.843. That's the slope of my curve at 1 for cosine. The other one was e. Negative 0.843. Okay, so now I'm going to change it one last time, and I have you guys speculate on this. So I'm going to change my function, and I'm going to make my function e, I'll do this, e to the x, which was the first one we looked at, times cosine of x. And that was the second one we looked at. So I've changed it to be a product of the two functions we looked at. So I want you to take a second. In a minute I'll hit enter, and we'll be able to see the slope of the tangent line and maybe confirm that your speculation is correct or maybe it's wrong. I want you to think. What do you think the derivative of this new function, evaluated at 1, would be? So think it over, write it down, use a calculator if you want here. Do some figuring. You had 2 decimal numbers that I gave you earlier. What are you supposed to do with those? I don't know. Yeah, we'll talk about that. See if you can think. What do you think the derivative e to the x times cosine of x would be at 1, bless you, using the numbers perhaps the numbers we talked about.
Sine of 1 is not, or cosine. Cosine.
You could use a calculator, right, to see, I'd be willing to bet if you did sine of, or, if you did, or negative sine of 1, right? If you did negative sine of 1, you would probably see a similar number to what you wrote down earlier. I would guess. So calculator on this little activity would be totally fine. A lot of decimals running around. I just want you to, so like we found, a second ago, we found the slope of the tangent line for E at 1, and then we found the slope of the tangent line for cosine at 1. And so what I'm asking is, what's the slope of the tangent line for e to the x times cosine? Or if we take those two things and we multiply them together, what's going to happen when we try to find the slope of the tangent line? We're just trying to arrive at a pattern. We're trying to figure out what pattern is reliable or not reliable, and what makes sense, what doesn't make sense. Okay, so some of you are maybe finishing up. I'd like to hear some answers from you guys as far as what you think the slope of the tangent line might be. What do you think, Hunter?
1.884.
So he says 1.884. Other ideas? Come up with anything different. So say again, Luke.
Negative 2.29.
Negative 2.287.
Or 87.
We're always going to be in practice of going to 3 decimals in our class. Once we start using the calculator more, we'll talk about that. But sounds good. We got 2 numbers up there, 2 possibilities. Anybody else with maybe a third option? All right. You guys ready to find out? Okay. So I think it's just going to just pop up here once I get off my drawing screen. Let's find out. So you see the 2 numbers up there. Let's look at this number right here in just a second and see if we get a match, right? Did it go yet? Let me see here. Oh, negative 0.8. So none of the above. Did anybody have that? No? Okay, so let me ask. Luke, what did you do to get your number?
I did negative sine of 1 times e to the 1.
Okay. So negative sine of 1 times e to the 1. Anybody else do that? Anybody find the derivative of e to the x? So just e to the x, right? Plug in a 1. And then the derivative of cosine is sine, a negative sine. Then you plug in a 1. Did anybody else do that? I am shocked. Oh, some of you were saying yes. Okay, I was going to say, I would have predicted that a lot of you would have done that. What did you do?
I did the derivative of both and then added them.
Oh, okay. So you essentially did negative sine of 1 plus e to the 1.
Yeah.
Got it. Interesting. Weirdly enough, the truth kind of lies somewhere in between.
Isn't it the derivative of 1 times, isn't it like negative
There is
sine
a little-
of 1 plus e to 1?
There is some, the thing is there's some multiplication that we'll need to do, and there's some addition we need to do. That's why I say it's kind of going to be this combination of the two, I would say. Okay, so let me just say this. Are you guys okay with the idea that this is not it? Like the derivative of a product is not simply just the derivative of the first factor times the derivative of the second factor. That's not it. And it's also not the sum of those two either. It's going to be kind of a combination. Nate, you had something to say?
Well, I did the derivative, so I did like e to the x times negative sine of x plus e to the x times.
Okay, so
cosine of x.
you have like seen this before perhaps, and maybe have,
But then I got negative 20.
Well, yeah, this is evaluated at 1.003. So we're off by like 100th or 1,000th. I'm not too stressed about that. Okay, so let's see if we can get all of us to where Nate is. And let me get to where you all are. There we go. Okay, so I think you're gonna find that once you see what you need to do, the doing of this is not that terribly difficult. It really isn't. Where I find students struggle the most is this second activity right here. And the second activity is all about, can you identify something that is written as a product? Because your identification of something that's written as a product or not is going to be the key to your success here. So, if you would, please look at A through I, and also I want you to write is yes, a product, or no, not a product. Okay, so you're answering the question, which of the following is written as a product? Put yes if you think it is a product. Put no if you think it's not written as a product. Yes for product, no for not. Okay. So let's just go in order here. What do you guys think about A? Yes or no for product?
No.
Number one is no. I agreed. It's a composite. It's a beautiful composite function, but it is not a product. It's not some factor times another factor. How about B? Yes, it is. The two factors are e to the x, and the other one is 4x cubed minus 9. How about C? Product, yes or no? C is yes, for sure, a product. It's a very simple product, right? It's just x times y, but it's a product. How about D? Product or no?
Yes.
D is a product. Agreed. How about E?
No.
Not a product. That's one sometimes people think is. It's not ln times anything. That's just the input for ln. How about number or letter F?
No.
F is no. You're correct. F is no. It's a sum, right? It's something plus something. How about G? Product, yes or no?
Yes.
G is yes. Yes, it is a product. How about H?
No.
H is not. H is a sum. And how about letter I?
Yes.
Okay. So assuming that you were able to track and get all those correct, I would say you have the first, and for a lot of folks, the most difficult step handled. And it's the recognition or the identification of whether something is or is not a product. And we're going to be focusing on products here. So this is where Nate kind of landed. If we are differentiating a product, we have to use something, amazingly enough, called the product rule. The product rule. So here's the product rule. I'm going to give you the very symbolic version of this, and then, as you can see, an easier way to remember this, I'll give you that way too. And to be honest, when I'm doing this, I'm thinking about the easier way. The easier way is genuinely the easier way to remember this. So here we go. The product rule, using just symbols, would look like this. So do you see how it's sort of a combination of what these two gentlemen said? Like there's definitely some multiplication going on, there's definitely some addition going on, but it's a combination of the two, right? Okay, so I'm probably never going to present it that way unless I need to. I'm going to always think of it as the easier way. So an easier way to remember this, this is not original with me, but it's good. It's really good. 1d2 plus 2d1. Something I learned in high school a long time ago. 1d2 plus 2d1. It sort of goes together. It's sort of poetic. It doesn't rhyme, but it flows nicely, right? 1d2 plus 2d1. Here's what we're talking about. 1 is just referring to the first function. You see that? 1 is just the first function. d2, that stands for the derivative of the second function. So there's your 1d2. So first times the derivative of the second plus 2d1. So 2 just stands for the second function as is. And then d1 that would be the derivative of the first function. So maybe you can see how those things are supposed to kind of go together. And honestly, when I was writing out that expression at first, in my head I was saying 1d2 plus 2d1. I've been doing this for a long time, and that's just how I remember it, so maybe that might still work for you guys. Okay, so like I said, the hardest part, I bet you if I gave you a pop quiz in 10, 20 minutes on this, you could write down 1d2 plus 2d1, and you might be able to even write what it means. No problem. However, the biggest struggle that people have is identifying whether some expression is or is not a product. In other words, recognizing when you need to use this or not. That seems to be the biggest struggle, so we'll keep working at it. All right, so let's take a look here at number 1. I wanted to do a little guided practice here, and then I'll kind of get you guys rolling. And by the way, all the stuff we work on today, and honestly all the stuff that we work on tomorrow, is going to really nicely tie into your quiz 4 on derivative skills, because we're going to continue to work on derivative skills. And if you're a little shaky on the chain rule, guess what we're going to be doing today as well? The chain rule. So like all these things are going to get nested together. There's going to be lots of opportunities for reviewing and going back, as well as this new stuff too. Okay? Let's do this first one together. And like I said, the hardest thing that people deal with on these is recognizing when or when not to use the product rule. What is the number one indicator on this first one that the product rule is something we need to do to find G prime? Why would I choose to do the product rule?
There's a multiplication sign there.
Yeah, it's a product. You can see that it's some function times some other function. Is there any value to doing a rewrite on this before we do any kind of a derivative? Yeah, the radical, right? So let's do that. So g of x equals x to the 1/2 times sine of e to the x. So here we go. In my head, I'm thinking I got to do the product rule, so I'm going to do 1d2 plus 2d1. Let's just take it one part at a time. What would you guys say is 1? Say again? Root x. Yep, there we go. So there is my 1. d2, isn't that going to be the derivative of sine of e to the x? And I have to use a chain rule. Why do I have to use a chain rule on d2? Because it's a composite function. Yep, so let's do that carefully here. So 1d2, what's the big box on my 2? Sine of something. What's the little tiny box on the inside? E to the x. Okay, so what's the derivative of the big outside box? So it's going to be cosine of e to the x times the derivative of the inside is e to the x. Okay, so do you see how the main focus here is the product rule? Do you see how there's a little chain rule mixed in? We kind of had to do it when we got to d2. So that's 1d2. Now I have to do, to complete my product rule, I have to do plus 2d1. So Cole, what's my 2?
T would be sine e to the x.
Yeah, sine of e to the x. There's my 2. And then I got to finish this off by multiplying by d1. Kaylin, what would be d1 for this?
d1 would be 1/2 x to the negative 1/2.
Perfect. Okay, so there's all kinds of ways that this could be simplified and rewritten. I don't feel compelled to do any of them because I wasn't told that I had to get into a certain form, right? So I'm just going to leave as is, okay? But that would be my product rule. And again, can you, watch the timing on this. Can you guys see 1, d2 plus 2, d1. See the different parts in there, right? Any questions? Okay, silence. Maybe that's good. You guys try number 2. Please try number 2. Cole, your question. You're doing 2d1 plus 1d2. So because it's addition, it doesn't matter, right? So I'm totally fine if you do it that way. Just know that, I think it's tomorrow. Tomorrow we're going to talk about something called the quotient rule. and there's subtraction involved in that one.
Yeah, so
And in that one, the order very much does matter, but here it doesn't matter, so I'm fine if you do it that way. No problem at all. Okay, so here's number 2. Hopefully you can see you're getting a healthy dose of chain rule on just about all these. Where we landed. It uses this magical phrase, find the slope of the tangent line. When you see the find the slope of the tangent line, what are we really talking about?
Derivative.
The derivative, f prime, dy dx, g prime. In this case, it's f prime. And I'm trying to like help you out here at the start. Like it says 3x minus 5 to the 5th, and then I put the dot. Right? I'm trying to like, as loud as a dot can yell, I'm trying to say, use the product rule, right? So, hope you did. So, let's see here. We're going to go f prime of x equals 1 is just 3x minus 5 to the 5th. D2 gets a little trickier, right? So, D2, you're going to have to use a chain rule. And I would maybe write it like this, times negative pi sine of pi x. I just pulled that chain rule factor out to the front instead of the back. It's the same thing. Okay, so there's 1d2 plus 2. It's just cosine pi x. And then as I walked around, I noticed that d1 is a little harder, even though it looks simpler. What do you have to use with d1? It's a chain rule. Isn't it a composite? It's something to the 5th, and the something in there is not just an x. So I would say that the derivative of 1, or d1, would be 5 parentheses 3x minus 5 to the 4th. Almost everybody had that, but then some people forgot times 3. Right? Isn't the derivative of the inside 3? So you're going to have to multiply by that chain rule factor to complete that part of the derivative. How we doing? Any questions? This is the main part, right? So you're supposed to plug in a 1 because it says, find the slope at 1. So we'd say f prime of 1, and I don't know how far we go with this. 3 minus 5 is negative 2 to the 5th is negative 32. And then what's sine of pi?
0.
Oh, isn't that lovely?
Right.
So times negative pi times 0. So that whole first term is just going to 0, isn't it? That's kind of nice. And then cosine of pi is negative 1 times 5, and then that's just 16, isn't it? Times 3. So first term goes to 0 plus 15 times 16 that's 240, isn't it?
Mm-hmm.
So negative 240. So there you go. Some of that, I don't know, should you be able to do cosine of pi? Yeah. 15 times 16, you should totally be able to do that. At least it wasn't like 15.936 times 16 and 1/17. That to me feels way overboard, right? 15 times 16, kind of a bigger number, but you can do it, right? I hope you can. How'd it go? That was your first foray, kind of all by yourself in this class with the product rule and chain rule stuff? Okay. So I think number 3 is a really nice one to talk about again, unless you have a question on 2. Feel free to interrupt, because you're not interrupting at all. 2. Okay, 3. A little different, but still a nice example. Super curious to see what you all do with this. So please take a look at number 3. Got about 6 minutes left, so this will be our last one in our class today. And maybe you've noticed that there's always plenty of examples. I think there's 2 more. Yeah, there's 2 more. So I really like number 5. I wish we had time to really delve into 5, but I think 3 is a good one. So I'd encourage you, as you look at studying for a quiz off in the future somewhere, or a test, you can always go back to these handful of examples here and there and treat those like practice questions and good discussion points. And I think that would be, those are all really good questions. I just felt like as I was writing these, I felt like I wanted to have extra examples instead of running out of them. So I always gave myself 1 or 2 extras each day. So I'm trying to get to all of them. let's just leave it, yeah, because obviously you're gonna get like some trig of 2, right? Let's just leave it in that form. I would say, like, from a quiz or test perspective, this one could easily be on either section, like a calculator active or no calculator. Yeah. Take another few minutes here, see if you can get number 3, I guess it is. Is this 3? Yeah, 3 to a good spot. I think number 4, which we will not get today, is largely procedural. Doesn't mean it's bad. I really like number 5 because it's a thinker. So if you, later on today, later on this week or next week, if you wanted to try number 5 and then we could discuss, more than happy to do so. It's a good question. You guys remember that one yesterday where there was like 15 zeros on the calculator? Remember that one? I went back and looked at my notes because I like went through and did all these, and like, sure enough, I found all 15 of them, and I just was like thinking to myself, like, why? Why would I think that that would be a good use of time in class? I don't know what I was thinking at that moment. So I must have just got wrapped up in the, look at all those zeros, I gotta find that. There's a pattern to them too. I didn't have to use the calculator and like use the zero finder on every single one of them. I found a pattern and I just like started adding the appropriate things. I think it went a little faster. I don't even know what I was thinking, but in retrospect, I don't know. Maybe not the best choice. Note to self, next year, change that one. All right, so here we go. We've got about 3 minutes left, so I want to close this one off. So we're supposed to find h prime of 2. So before I find h prime of 2, what do I have to find first? H prime of x. So I'll plug in the 2 at the very end. So then I look over here and I see this lovely expression for h of x, and I think, well, I need to do a derivative of that. What is my first hint that I have to use a product rule?
Next to each other. There's no other signs.
It's a product, right? I mean, it's like a parentheses butted up against f of 2. I mean, it's a product. It doesn't have the dot, but it's still a product. So here we go. H prime of x then would equal 1. D2 would be this. I'm really hoping you got this. Oh my gosh, I'm going to reveal it now. It's going to be so awesome. Did you get this for 1D2?
Yes.
Cosine of x times f prime of 2x times 2. Did you remember the times 2 part?
Yes.
It's a chain rule, right? Because that's a composite. F of 2x is a composite. So that's 1D2 plus 2 D1. Of course, D1 is not a chain rule because it's just cosine of x. So obviously beyond this, we're going to be plugging in a 2. But do you have any questions on that part?
If we didn't have a calculator, could we just leave it as cosine of 2?
That's how I'm going to leave it. Yeah. So I'd say h prime of 2 equals cosine of 2. I don't know what that is. F prime of 4, I'm told, is 2 times another 2. F of 4, I'm told, is negative 3 times negative sine of x, or sine of, 2. So I'm going to get h prime of 2 equals 4 cosine of 2 plus 3 sine of 2. And without a calculator, obviously, I'm leaving it there. Let's just do this last part verbally. What's the graphical meaning of that? Slope of the tangent line at 2, or you could also say, I think you said it too, slope of the curve, slope of h of x, when x equals. Okay. Hey, thanks to all you that did retries this morning. I know there was a lot of them. We got them all done, I think. I was trying to get everything all settled, and I think we're good. We can do round whatever it is tomorrow, if you want to come in. I'll be in later in the morning because I have a Bible study, but then Thursday and Friday also fair game. So keep that in mind. All right, have a great rest of your day. See you guys. Kaylin, what's up? Thank you, Hunter. I'm trying to listen.